Good afternoon. Welcome to First Fridays at the Cedars, and it's great to see so many people out on such a beautiful day. Told Gail we'd have to go out and take a walk later this afternoon. This is fun for me at a couple levels. One, when I was at McPherson College, I was asked to, on behalf of the college, put together a program called First Fridays at the Cedars. And our very first gathering was 6 years ago today. The program has been running that long, and it's great to see it coming. This is also my final Friday hosting here at the Cedars, because 1 week from today will be my swan song, my last day here, and it's been a real joy. And because there are so many of you here who have supported Vision 2020 and the Cedars in so many ways, we will be announcing that we have exceeded our campaign goal, probably somewhere around $75,000 or $80,000. So that's really significant. Give yourselves a hand. It is indeed a privilege to have Allan van Asselt here, and one of the things that Norma Tucker told me when she was dean at McPherson College is that as a chief academic officer, one of the greatest joys is employing really good faculty. And I had the opportunity when I was dean to bring Allan on board and steal him away from Bethel College, about 30 miles south of here. And I can tell you from sitting in on his classes that he is an extraordinary teacher, someone who is willing to go the extra mile when a student has difficulty. So we'll see if the students in the back of the room will affirm that. But I see some heads nodding yes. But welcome, Allan. We're glad you're here. And I'm going to turn it to Monica at this point for her announcements and updates from the college.
Thank you so much, Steve, and Happy New Year. I am so happy to see so many. It was almost a bring your own chair situation because so many of you are here to hear Allan, and we're so glad that there's also a family and a student fan club that are here for this presentation as well, so welcome. And as Steve said, Dr. van Asselt will be sharing today, and his topic is about astronomy. So when I invited him to consider making a presentation, he did not hesitate at all. He said, I'd love to talk about astronomy. And so this past week, as we were planning this presentation, I asked if there was any special room configuration that Allan would like, and he suggested that we set the tables in the constellation of Orion arrangement. So I'm not sure if Diane got it perfectly right, but maybe at the end of the presentation, we can challenge Allan to tell us what this constellation actually is. So, next month, February 1st, we will hear from Dr. Ken Yan, and he'll be speaking about ISIS, democracy, and refugees, civil war in Syria. And for those of you with good memories, this should sound like a familiar topic. We were hoping to hear Ken speak last October, and unfortunately he fell ill that day, and so we were very grateful that Kirk McGregor stepped in and shared a great presentation. But we're happy that we will have the chance to hear Dr. Yan share about this very timely topic. So make sure to come back next month, February 1st at 3 o'clock on that Friday. So with that, we will welcome Dr. van Asselt. Thank you so much. 45 minutes.
Okay, I think am I sounding louder or whatever? I'm gonna start out actually with a quote. This is from my alumni magazine from Caltech. And in order to do this, I actually put on glasses, and then I'm going to turn a little light on here. Okay, Katie Mack was a bachelor's degree person from Caltech, California Institute of Technology, and is now a professor of astrophysics at North Carolina State. She said, here's a thread I posted on Twitter one Friday night. I feel the need to tell you a thing about being stardust. Yes, you are made of stars. Yes, you in particular, mostly. All that carbon, oxygen, nitrogen, etc., that was all made in stars. Most of your body is made of that stuff. Atoms that a star forged inside itself or at the moment of its unimaginably violent death. So yes, you are stardust, but only if you count by mass. If you count by number of atoms in you, most of those, hydrogen. Never part of a star at all. Most of your atoms have been in the universe for 13.8 billion years. Most of your atoms were forged in the Big Bang itself. I think that it's cool that we are made of stars, that our planet and our bodies and everything we touch can only exist because of the nuclear alchemy in the hearts of stellar infernos. But I think it's much cooler that most of our atoms have been in the cosmos all along. You are stardust, and you are the ashes of the Big Bang. And you are, at every imaginable level, a creation of the universe, vast and beautiful, and suffused with unbridled power. I just thought that was a very nice statement. I'm going to make a statement right now, which is that in order to avoid sort of saying, which I might anyway, according to our current models, which is kind of the scientist in me that says, you know, one of the things about science is that we change our mind, generally over a shorter or longer period of time. And I am relatively convinced that we don't actually understand the universe. At this point, we have, you know, inklings about a lot of things, and but our current model is the Big Bang, which through a variety of calculations and so forth, we showed, I think it was 13.76 billion years. And then those would be the same models that essentially say that the atoms that are in our body, the ones that aren't hydrogen, were created in the nuclear furnace inside of there. There's at least one other current model that's not as well developed in terms of the structure and formation of the universe, which, I mean, I literally a couple years ago went out to look for this other model because I'm thinking, just having one model of the creation of the universe doesn't make a lot of sense in science when you know that you're just working with models and that, in a sense, they're never going to be completely correct. So, but where most of I'm going to talk generally out of our current scientific model on what the universe looks like. This particular shot I just left as an opening shot. This is in Spain. And the photographer happened to notice how interesting the oak trees looked after they had been pruned, and so got up in the middle of the night, I think this is about 2 a.m., and then lined himself up so that you could get it almost looks like the branches of the oak tree just go on into the Milky Way. So you can see the Milky Way is essentially the bright band that goes down through there. I'm going to go back in just a moment and I'll show you some of the, we'll just go through some of the quick terminology associated with this. The biggest problem with this is generally just going to be that I have way more things to talk about than I'm ever going to get to. So we'll just work our way on through. Just a little bit about my background. So I am not an astronomer. I'm actually trained as a PhD chemist. And so I just, because some of you, this would be very relevant to you, I learned constellations from John Burkholder. He came out to our scout camporee and showed us those. I took astronomy in college from West DeCourcy. So one of my memories is going to the roof of Harnley with the telescope and looking at things, which was probably one of the first times I actually ever got to look through a telescope. I know most of you, probably have traveled to Colorado in your lives, and you may or may not have the same experience as me, but it used to be a lot darker in Colorado than it is now. You can still get great skies in Colorado, but back in the earlier days of my life, it was unbelievable what it was like to go outside at night and see the stars. And then to think about the fact that throughout almost all of human history, that was people's experience of the universe, was going out at night and this incredible set of stars and being able to see the Milky Way and things like that. I also read a lot of science fiction and so forth. I went to graduate school at Caltech, and Caltech administers JPL, which stands for Jet Propulsion Lab, or at least it used to. The jazz band reference there is the fact that I played third trumpet, and the second trumpet player is named Rob Manning, and he was the mission head for the Opportunity and Spirit rovers landing on Mars. And when they just landed the InSight here about a month ago, which I happened to turn on the NASA TV 5 minutes before they landed, oh man, that was cool. He was the person that they were interviewing. So I have some almost personal connections into the people who are currently exploring the solar system. I was part of the Space Weapons Study Group. This was at the time of, quote, the Star Wars, the Strategic Defense Initiative, when I was in graduate school. So we looked at a lot of issues related to whether it made sense to put an anti-ballistic missile system there. But one of the guys who was in our group was one of the maintenance guys who worked down at Mount Palomar. So when I was growing up, Mount Palomar was the largest telescope in the world, and I mean the largest mirror. And so we actually got to go down there, and we had access to, I think, a 60-inch telescope to look at Saturn. So I don't know, how many of you guys have ever seen Saturn through a telescope? It is just unbelievable. I mean, I don't know why it's so cool, but it is so cool. And then we actually got to go up into the big telescope, and we're in the cage, and apparently he got in a lot of trouble for letting us go in there. Other things, then we were driving through the back roads of New Mexico one year, going to my sister's, and we came next to the very large array. I'll show you a picture of that really quick. That's the giant radio telescope that's down there. Many of you guys know Thelma Sheets, and then Jim Sheets is her son. And you may have remembered a couple years ago that he had an ambulance that he had converted into a little observatory. And I took a number of astronomy classes to him, and we looked at things. And then just in the last year or so, friends of mine, the Kegels, have bought a telescope. So I've been out in the last month or two looking at a variety of things. I got to see Saturn again, actually could see this spot on Jupiter. It was pretty fun. I teach astronomy. I took a massive open online course about 2 years ago from one of the guys at Caltech who basically studies the solar system. In fact, it's his research group that is probably most responsible for having lost Pluto as a planet. And the reason is because they had started to find multiple other objects out in the outer solar system. Pluto does not share the same orbit as all the rest of the planets. There are a whole variety of reasons why you either have to start calling all kinds of things planets or you had to make a definition. So that's still kind of controversial, but that was an incredible thing. I was teaching at the time. It was kind of hard to do this, but I had to pass this test every week and so forth to go on and do that. And then I'll just show you, the last thing down here says basically the 2017 eclipse. So how many people in here got to see the eclipse? So there was a group that went from here, right up on the bus to, I think, and we were up in agate fossil beds, and oh man, anyway, that's another one of those experiences that can't explain very well. So this, let's see, how do I get the thing on the bottom to not show up? Let's try. Okay, so that one there, this is us at the VLA. I don't know, you can see right down in here. No, I guess if I put that on there, that's what the problem is. The one I'm standing over there on the left, and then that's Grace right there, and then Caitlin is right there, and I think our son Carrick took this picture. And so this gives you an idea of what a single one of those radio telescopes looks like. This is the array that is built on 3 train tracks. And so you can change the focal size of the telescope. It's multiple giant telescope receivers like this that you can move them in and out to make to change the resolution and stuff on the system. And then this is where we actually went to see the eclipse. Just a shout out to the Park Service. They did an incredible job. I heard someone saying that on a normal day, when it's really busy, they might get 100 visitors in this park. This is actually a national monument. And they estimate they had 11,000 people in that park that day. And this is like way out in sort of nowhere, Nebraska. Very, very beautiful part of Nebraska, actually. And so this is an actual picture from Caitlin's phone, sideways, but where you could look and the twilight was 360 degrees around you because you're in a shadow. Actually, it's not like a normal twilight. So this is 11:48 in the morning, and you can see twilight all the way around. And then this would be a NASA shot of that, which just doesn't really capture the experience very well. Okay, I don't want to spend much time on this, but the reason I'm doing the talk now is that this talk in particular is called Astronomy Picture of the Day, or I call it Astronomy Picture of the Day. And so in Chem 1 and Chem 2, pretty much every Friday, I go through the last week's worth of pictures in the Astronomy Picture of the Day. And this would be a variety of reasons why I think that is actually, it's fun for the students. It's really fun for me. I'm always excited to do it. And then I began to realize one of the things that happens in all of education is we focus so much on the details that you really lose a lot of the bigger picture. Like how does the universe form? Where do things come from? All of these kinds of really big questions. We talk about atoms, and put them together in chemicals and things like that. So this gives a much larger perspective. I always think this is one of the more interesting parts of the current models in science, is that everything that you see in this room, everything that we can see out in space using light and so forth, is only 5% of the universe. That's our best estimate based on a variety of math and so forth. 25% of the universe is what we call dark matter, which we have really, really good evidence for because of the way things move gravitationally. And what it means is that it has mass, but apparently it does not interact with light because we can't see it. And then there's the other 75% of the universe, or 70% of the universe, that is dark energy, and we have no idea what it is. So our best current models of the universe have a 95% fudge factor built in, which might be an indicator that maybe the model isn't right. But anyway, there's a lot of reasons that people are very supportive of that model. And then all the things like, actually, do you understand how full moons work and all of that kind of system? So we talk about some of that in there as well. Let me just go through a couple of terminology, and I will try to make this relevant as we go back through. But a planet is what we're standing on right here. This would be considered one of the rocky planets, the inner planets in our solar system. So that would be Mercury, Venus, Earth, and Mars. Then we have sort of the asteroid belt, where there may or may not have been a planet. Currently, they don't think that there was. But then, whoops, okay. Then we get out into the gas giants, and so that's Jupiter and Saturn, and then Uranus and Neptune, and then the little ones that are farther out that we just 2 years ago flew a probe past. The Horizon probe went past Pluto, and it turned out to be way more interesting than people would have predicted, which is, if you're going to spend that much money and 9 years flying out into space, it's nice to find something you don't expect. And then some of you guys have been following the news the last couple of days. They took that same probe and they directed it towards the farthest object that we have seen so far in the solar system. So a solar system is a star, and so in our case, that's the name of our sun, is Sol in one language. So solar system is the star and the planets. And so that's really pretty much our neighborhood when it comes in terms of science things, or in terms of astronomical things. And so we were having a discussion earlier about, where is the edge of the solar system? It's really hard to define. Many of you guys would remember the Voyagers that went in the 1970s, Voyager 1 and Voyager 2. Voyager 1 punched through what we think was the edge of what's called the heliosphere, or the edge of the solar system, a couple years ago. Voyager 2 just did it about a month or two ago. The nice thing is that Voyager 2 has more instruments still working on it. And so it's sending back data about what the edge of the solar system might look like. And that's actually, our solar system is orbiting our galaxy, which is our large collection of stars. And so we're moving through space, and the sun is constantly putting off a solar wind, which is particles that are charged and are pushing out. And so one way to define the edge of the solar system is where the wind from the sun, so to speak, blocks interstellar material from coming into our solar system. So it's like having a bubble that moves around essentially in front of us. And so both of the Voyagers now have passed through that bubble. And they've been traveling since 1970s. I think they're moving something like 12,000 miles an hour or something. The New Horizons, the one that just flew by, Ultima Thule, which is the first picture we'll look at, or no, actually maybe the last picture, is going at 51,000 miles an hour right now. So it's moving pretty fast. Okay, the solar system, nebulas are big collections of gas and dust. So when we see a nebula, that's generally something that's in our galaxy. So the solar system is our local neighborhood. The galaxy is the large collection of stars. We live in the Milky Way galaxy. That's where the name, because it looks like milk, spilled milk on the sky. And the estimate is that there's over 100 billion star systems in ours. In the last 20 years, we've gone from no other planets in the universe that we knew about for sure to now thousands of candidates for others. So we're pretty sure that almost every star has planets associated with it, which was sort of an assumption, but nobody knew that for sure. And then there are actually galaxy clusters where you have a whole bunch of galaxies. We are in what's called the local, well, for some reason, the local group is us, and then the other really big one is called Andromeda. I think maybe there's a picture of Andromeda in the pictures I'm going through. And we are scheduled to run into each other, Andromeda and the Milky Way, in about 4 billion years, if you just want to wait around for that. But anyway, we're on kind of a collision course. It is not uncommon in space, apparently, for galaxies to hit each other. It's very uncommon for stars to hit each other. So the analogy would be sort of like, well, one is that a star is about, if the star was the size of a basketball, you'd have a star in Chicago and a star in New York. I mean, that's the relative distance. Galaxies are much, much bigger things, and so it's much more likely that they'll actually hit each other. And then the universe is, again, our current model is the Big Bang, which really, if you think about it, doesn't explain anything except that 13.8 years ago, nothing was there, and then that became the universe. And one of the interesting things about that is, where are we in that explosion? So, are we on the outside of it? Turns out, no, we are on the inside of the Big Bang, right? So, the Big Bang is the creation of the universe. So we are on the inside of this, and nobody can answer the question of whether there's anything on the outside of that. Anyway, it's a sort of a philosophical and a question you can't get there. Okay, I'm going to go back up here. Okay, so what I'm going to sort of go through a version of astronomy picture today. I'm going to probably skip over some of these pictures just because there's some I want to get to, and I have, again, more than we can do. So let me see what I can get this to. Okay, this is the very large array down there. You can see this is when they brought all the giant things in close together, and this is, of course, the crescent moon. This phenomena right here, I'm sure a lot of you have seen that. When you get a crescent moon, you actually sometimes can see the rest of the moon there, and that is Earth shine. So that is the reflection of the light off of the Earth, and then there's enough light there that it actually illuminates the rest of the moon. And so during the first couple days of the crescent, a lot of times you can actually see the entire moon in there. I just happen to I really like this picture. Okay, let me see whether I can do this. No, apparently not. I'm going to have to go this way. Okay. Just to get a little historical stuff in here, here's a shot from Apollo 15, a giant panorama. And I'm not going to spend much time on that, so let's go on. I'm going to run through a couple of these. This would be an example of a nebula right here. This particular color is one of the ones you're going to see fairly often. There's the actual colors that are in space, and then there's the false color images that you have to use when you're looking in other wavelengths of light. So if you're looking in the infrared or the X-ray or the radio, we don't have eyes that see those things. So they made up a set of colors that they put on top. So I think this is an actual color picture. This is called an emission nebula, and it's when the gases get so excited that an electron gets popped out of the hydrogen, usually because there's a star around there that's burning really, really hot, and then when the electrons come back down onto the hydrogen, they start falling down in energies. And so this is a really common color that you see in the nebula. So emission meaning it actually gives light off. And we'll see some other examples. Okay, this one, I don't know whether you need to actually watch the movie. This is just, well, let's just put it right there. We have a probe right now that is floating around an asteroid, a fairly close asteroid to us. And apparently that doesn't really want to come in. Okay, let's not worry about it. But the idea is we're going to actually land a probe on there, and then in the next 5-6 years, that probe will come back. The Japanese also have a probe that is on an asteroid and is set to bring back some material from the asteroid. So an asteroid is essentially a giant rock that's part of our solar system. And so, down the road, people are thinking maybe there'll be resources and so forth, but they're also kind of like pictures back in history. And so the Japanese probe is also hopefully bringing back some material. That will be the first time we've ever brought anything back from an asteroid. Okay, this would be one of the false color pictures, and so this is a fairly common, this is called the Hubble palette. So from the Hubble Space Telescope, they have a set of colors that they chose. So blue, I think, corresponds to hydrogen. The greenish colors are associated, I think, with oxygen, and then I think maybe the orange is a sulfur or something like that. But this is essentially, these are where stars are born. So again, in terms of our overall picture, the galaxy is our giant collection of stars. And so there are multiple places in our galaxy where the dust is a little bit higher in concentration. And that's what can then get triggered somehow to start forming stars in the process. And I don't think this is the particular example, but a lot of times, say, a star would be forming out in one of the fingers in one of these dust clouds. And if you look in the infrared light, sometimes you can actually see through the cloud and you can see the formation of the star taking place. This one's going to show up a lot. There was a comet that came through that was visible to the naked eye if you went to a really dark place. It turns out that's actually getting hard to find. And so they called it the Christmas comet. So some of you may have read about it, but this is a fairly blown up version of that. And so this color is fairly indicative of it. It's kind of a greenish color. A comet is distinguished from an asteroid that an asteroid is pretty much a chunk of rock. A comet is generally called a dirty snowball a lot of times. That is mostly water with a lot of dust in it. So when they come down towards the sun, they heat up, and then that blows the dust and stuff off. And this particular comet has been around enough times that it doesn't have much dust anymore. But that's where the giant tails come from that are on a comet, is because you're warming up the ice is then evaporating, shooting gas out there, and then you get this giant trail. And so a comet is actually usually a really, really small object. You would never see it with your eyes, but then the tails on comets can be massive, and that's where you get the giant comets. We haven't had a whole lot of really visible comets. That's another thing I can remember going out with John Burkholder and Doug, his son, and with binoculars, and we went to look at we went out to the west side of town and found a comet that was out there one year. So that would probably be they will eventually evaporate is the idea. And there are some models that think that most of the water on this planet actually came from comets that hit the planet after it cooled down. But that's also kind of controversial in terms of there is just so much we don't know actually. Well, yeah, I could go into the science of why that's not completely there. We were driving down to the airport on Wednesday morning to take our Thai student back to the. He arrived in Bangkok this morning about 12 hours later than he was supposed to, after 2 days of travel. But anyway, as we were driving in the early morning, and there was the moon and Venus and Jupiter. And so this is Venus and the moon from about a month or two ago. Earlier in the process, and it's kind of a pretty picture. You see the Earthshine thing there too. Okay, Transition Nebula. This would be the one nebula that's actually not in our own galaxy. We have at least there's 3 companion galaxies that we know of. The larger Magellanic Cloud and the lesser, when you can see those from the southern hemisphere, and then one that's on the other side of the galaxy that's really hard to see. They just sort of in the last couple of years have decided that there's one there. This is actually one of the biggest star-forming regions that we can see, and it's in the galaxy that's right next to us. And back in, I think, 1984, there was a pretty major supernova explosion in this region, which gave us some of our best data yet in terms of supernova is essentially when a star starts to run out of fuel, then there's stars, again, in our current models, stars have a nuclear furnace going on in the center, and then there's gravity pulling on the outside, and that's constantly in balance until you burn out your fuel, and then the star contracts, and then it heats up, and it burns some more. And you can get, if stars get to be a certain size, then that gravitational process of contraction doesn't stop, and it just keeps getting hotter and hotter and hotter, and then they explode, and a supernova can put off as much energy in this short explosion as the rest of the galaxy out of the 100 billion other stars. So these are one of the best ways we have actually the supernovas of trying to figure out how far things are away in the universe and so forth. So you can see there's a whole star cluster right here in the middle, again, because these are the places where new stars are being formed. So here's just a quick trivia question. So if you have a really big star and a really small star, which one's going to live longer? Turns out the small one. Really big stars, some of them last but from an astronomical point of view, only 100,000 years or a couple million years. You might know what the current age of our sun is, our best estimate?
5 billion.
About 5 billion years. And then we think our sun will last about 10 billion years before it goes through a process of expansion. It will not do a supernova, as far as we know. That is not the model. But it will expand enough that the outer atmosphere of the sun will encompass the Earth's orbit. So it might not be a very comfortable place to live at that point. Okay, there's always a couple of really cool shots of things like auroras. And so there's one. This is from this, I think, November, somewhere in Sweden or Norway. I read all these things earlier. This is just a particularly nice thing. So auroras are, so one of the things that most of us never think about at all, that we are really lucky to have a magnetic field on this planet. Because it is the magnetic field of this planet that protects us from the solar wind. So the sun is constantly, I mean, sometimes in giant explosions, but it is constantly streaming these high energy particles out into space. And so if they have charges on them and they hit a magnet, then that magnetic field tends to deflect it. And so when those deflected particles come in the poles of the magnetic field, so that's why you see these things in the North Pole and you see them down on the South Pole. So those charged particles are coming in, and when they hit atoms and molecules in the atmosphere, they cause those atoms to light up. And so the green is oxygen, and the purple is associated with nitrogen in the atmosphere. In terms of, if you teach geology, I'm doing geology right now, or the lab, in astronomy, you collect all different ways that we can die, or that major problems could happen. One of the interesting things about this is in the 1850s, there was a coronal mass ejection, so an explosion on the sun that sent particles to the Earth that started telegraph wires on fire. They could see the aurora in Cuba. So that's not very close to the North Pole. And that people could read the newspaper in New York City under the light of the aurora. It is not, I don't even think we can imagine today what it would mean if we got an electrical pulse like that on this planet. How dependent are we on electronics at this point? So anyway, but if they're not so bad, they're really beautiful. So how many people have actually seen a good aurora? So where'd you see it?
In Colorado.
Uh-huh.
How did it get that far?
Well, if it's really bright, then apparently you can see it farther south. My brother-in-law saw it up by Lindsborg a couple years ago.
Minnesota.
Minnesota is a pretty good place. Anybody been farther? Northern Illinois and Alaska. Alaska is supposed to be one of the great places, right, to see it. I think the only time I've ever seen it was flying to Europe, and you go up past Greenland, and I could see it there. But I just love this picture. I don't know why. It makes me think of science fiction or something. This is a mountain in Sweden with a gibbous moon right there, and then a little airplane. I don't know, there's just something I just really like about that picture. Okay, this, well, let's not even worry about that. This is the object that came into the solar system last year, and then when it left on a slightly different trajectory than what they thought. And so there's a variety of explanations, one including that it was an alien spaceship, but that's not the, I think, accepted version right now. These are pictures of Jupiter's atmosphere. I'll show you another one here in a moment, so I'm going to not spend much time here. The Juno probe, which was actually functional when I was taking the class on the solar system, was specifically built, so Juno is the wife of Jupiter, right, in mythology, and the Juno probe is made so that it flies really, really close to Jupiter and then goes way, way out, and then it flies really close to Jupiter and then goes way, way out. And by getting really close to Jupiter, they can measure the gravitational field. And so while I was taking this class, this guy who's an expert on the solar system was saying, well, this is the best model we have for the formation of Jupiter. The data came in while we were taking this class from Juno and said, oh, that model is wrong. Again, if you're going to spend millions of dollars on a space probe, maybe it's good that you find out things that you don't expect. So this one is in the process. I think it's gone through its 14th loop, and so it keeps going past, and by the time it's done, it should have essentially close-up pictures of almost all of Jupiter, and then have measured all the gravitational field there in that process. Okay, this would be another false color image of a nebula. These little globulars right here, these are pretty much where stars are forming. So inside of that, this would be called a dark nebula where you can't see through it. And those little globules are generally, when we look at them through the infrared light, you can see inside and see that there's the formation of new stars in the process there. Okay, so some of these actually have nice illustrations. So there's Canis Major, so that would be Sirius down there. There's Orion, but this is one of the Leonid meteors. So I didn't define meteors, but so what is a meteor? You guys know what a meteor is? It's a flash of light in the sky, right? Or falling star is the other name for it. It's a meteoroid out in space, like asteroid. Excuse me. It's a meteor when it's in the atmosphere. It's a meteorite when it's on the ground. And so most of the meteors that we experience and the falling stars are little dust particles left over from comets that have passed through our orbit. And that's why every year at certain times, so the Geminids was just about a week ago, I think, because I saw at least 3 meteors sitting outside. And so they come from the same part of the sky, and then every year when we pass through that part of the orbit, we get meteors. So that's why if you go pay attention to these things, they'll say, oh, there's the Leonid meteor shower, is tonight and tomorrow night. And then there's a really nice one August 11th. And there's a whole series of these meteor showers. So this is one from the Leonids, and then just sort of another pretty picture of the landscape there. This is off the coast of Namibia. And it's apparently this used to be where lots of whales and stuff would beach themselves, and now it's known as a place where there are a lot of wrecks. You can see the moon there beginning to set, and then I think this is Venus, and that's property Jupiter, and those are just so big because of the light absorption in the camera. But let's see, what do they call this one? The shipwreck at moonset is this picture. Okay, this is one of the moons of Mars. Mars has 2 relatively small moons. They are way closer to the surface of Mars than our moon is, and they're probably going to crash into Mars at some point. Again, that would be farther down the road, but this is like 4,000 kilometers, and our moon is like 30,000 kilometers, or 300,000 kilometers. And they think these tracks here are from when something hit this thing, and so the current model is that maybe these tracks are from boulders rolling away from that collision when that happened. They also think that these moons are probably captured asteroids for Mars. Okay, I want to show you this one. I'm going to go ahead and probably do this full screen. Okay, so this is from the International Space Station, and I debated whether I was going to show you more movies from there, but because there are some great movies. One of the things about the International Space Station is really not that high. I mean, as comparative things go. The other thing that is pretty clear, if let's just look at some of these pieces right here. This is the atmosphere. So how important is the atmosphere to us? It protects us, and it's what we breathe, right? If our atmosphere was gone, we would not be here. And if you look at it, think about how big the Earth is, how big that ball is, and how small this is. So the atmosphere, again, is 100 kilometers or so that'd be about 60 miles. Again, you can't say exactly where it stops. This is a kind of a sort of glow that is constantly there at the top of the atmosphere, again, from molecules getting excited by cosmic rays and so forth. So this is from the International Space Station, and I think it was November they launched the Soyuz resupply rocket, and so this is the video of them watching the rocket. Because it's really, you can see the rocket go up, you can see it go out of the atmosphere, you can see it deploy the second stage, and then you can see it's one of those, it's like the new ones, the SpaceX ones, you can actually see the rocket going back down. So you can go look that up if you want. It's on the 26th of November. Okay, this is from the InSight. This was the first picture after they landed on Mars. Not very clear because they still had the dust cover on the surface of it. So that's the probe. It is not a mobile probe. Mostly what they're doing with that probe, a lot of is they put in like a seismometer and the ability to listen to what's going on Mars, besides various chemical probes and so forth. Here again, you would see these are the emission nebulas. I think, and then this would be more of what we call a dark nebula, which is just kind of a cloud where you can't see through. And then I'll show you an example when we get there of what the other one's called a reflection nebula. And so this particular one is down in the southern hemisphere. So these would be what you call reflection nebula. And so it turns out when you shine light with all the different colors in it, the light that is most likely dispersed is blue light. So that's why when you look outside, the sky is blue. The sunlight comes in, and then the molecules of the air cause blue light to scatter. And so these would be reflection nebulas. So these stars in the middle are shining really brightly, and then the gases around the outside are reflecting in that. And that's where the blue color comes from. And then these would be the dark nebulas here. It doesn't seem to be much in the way of an emission nebula in this particular picture. The other thing you notice is the different colors on the stars, and that correlates to temperatures of the stars. And that determines a lot about how long they live and so forth. This is kind of just a nice one in the north. Here's Orion. If you're into this, you can go out tonight and see Orion relatively early evening. The trick generally is to find the 3 stars. There is nowhere else in the sky where you have 3 stars that look like they're right there together in a line. And then this would be the belt of, or this would be the sword of Orion. This is actually the closest star-forming region in our own galaxy. So it's like 1,000 light years away, and there's a bunch of stars forming in there. This is the very famous star Rigel, which is a very bright blue color. And then, depending on how you want to pronounce it, Betelgeuse, whatever, it's a very noticeably red star. And it's a red giant star. It's a massively large star. Which is why it's actually so bright. Now, one of the things about constellations is that these stars don't have to be anywhere near each other in space. It's just that they look like they're near each other from our point of view. Okay, this is Mount Everest. So this would be, these are star trails, and so they took a series of exposures. I think this is from base camp if you're going to go climb. So anybody here climbed Everest? Okay. Okay. There you go. And so, of course, the whole thing is it looks like the sky is moving, but of course that's not the answer, is it? We are moving, and then that makes it look like the sky is moving. We're rotating, and so if you take multiple exposures, and then again here I think you can see really well the different colors of the different stars. And so bluer stars are hotter, and redder stars tend to be cooler, and then all the different variations in there. I think that's also just a really pretty picture. Okay, I'm going to have to make this one a lot smaller to get it on here. This is, some of you, I'm sure many of you have seen the very famous Eagle Nebula pictures, the pillars. Those are star-forming regions. This is, again, a false color image. This is an infrared image. And they talked about it, somehow this is supposed to look like a fairy or something in here. But again, this would be places where new stars are being formed inside of those dust clouds as they coalesce. Okay. Okay, we're not going to do that one. This is a rocket launch in China. You may have caught that the Chinese just landed a probe on the back of the moon. And so I was thinking, so how do they send the data back? Well, it turns out they also put a satellite that's going around the moon, and that's how they're getting the data back. So the back side of the moon, which a lot of times we call the dark side, is really not dark. Well, it is dark when it's night on the moon. But the fact is that the moon is locked tidally with us, so it always shows the same face to us. But of course, as it goes around, it's actually doing, it is also rotating in that process. And so the other side of the moon is, we think, a lot more primitive than this. We've taken a lot of pictures of it, but this is the first probe that's ever landed on it. So it'll be interesting to see what kind of stuff they pull back out of that. That's just a couple of well, I guess the one thing about this is the most recent supernova that has been found. This is the galaxy right there, and then this is, I think, the supernova that they found in that. So people were paying attention. Somebody was looking to go, hey, there's a star there that didn't used to be there. And so that's the most recent supernova that is visible anyway. And then this is the picture of the comet. This is somewhere in Spain. There are a bunch of pictures of the comet. Let's not worry about that one. Here's a nice aurora one with the combination of one of the meteors. So this is up in Norway, I believe, showing the aurora and a meteor. Okay, so this is the higher resolution picture off of the InSight. Again, so this is the most recent probe that landed in November, or maybe early December. And so they took the dust cap off, and you can see the rest of the probe. This is the actual color. The Martian sky tends to be kind of a reddish color. Almost all the soil on Mars is kind of, well, essentially it's rust colored because it's rust. I mean, it's iron oxide, at least a lot of it is. One of the things I learned in the course that I took was that we have all kinds of evidence that there has been water on Mars. So really the question is there any liquid water left on Mars? And there's even some speculation that may be true. Okay, so this would be an example of a galactic collision. So this is what we call a spiral galaxy, more or less, but you see this giant tail here. So presumably what happened was two galaxies got close enough to each other that their gravitational pull started to interact with each other. Okay, that would be an emission nebula. This is actually in the Orion Nebula, kind of looks like a waterfall. So this is the closest star-forming region to us. This is a 3D image of the thing that we're going to get a sample of, but we don't have any 3D glasses. So this is one I want you to see. So this is, I think, the last Juno trip. Let's see if I can get this on here a bit. Now, this is 3 different shots, so look at this thing. It looks like there's a giant dolphin in the atmosphere of Jupiter.
It's really a pretty picture.
Isn't it? I mean, so the only other place where I see these kinds of patterns is like if you get into rocks and you start looking at polished rocks and you look at, and then really you see kind of images like this. I just think this one is pretty fun. It's presumably not a dolphin. That dolphin is, or that feature is larger than the planet Earth. Okay, so it's a very large feature. So there's a nice shot. So if you put your camera up in the sky and open it up for a while, you can see colors that your eyes cannot see because our eyes are not built to work in the dark very well. And so this is actual color out of the sky there, and then you can see the whole series of the Leonids coming in there. And then this is, I think this is maybe the comet, but we are really getting close to out of time. So our galaxy looks, this is actually Andromeda. So this is our nearest local large neighbor, about the same size, maybe a little bit larger than the Milky Way. This is one we're going to run together in about 4 billion years. There's an artist's rendition down here of what it would look like when we run into each other. But I don't remember which one it is. Okay. The invisible, well, okay. I'm not going to find it. It's going to take too long. But this is more or less the structure of our galaxy. We have the center, you have a lot of stars very densely located, and then you have these long arms that go out. And we live, this isn't our galaxy. We have never been out of our galaxy. We've barely been out of our solar system, which is right here. And so this is probably kind of what ours looks like. And we live out sort of in one of the outer arms of our own galaxy in the Milky Way. Oh, this is such a cool picture. So this is the largest freshwater lake in the world, holds 20% of the freshwater. You might know where it is? It's in Russia. These are methane bubbles that got trapped. So this is pure ice, really clear, pure ice, and then these are bubbles of methane that are trapped. This, of course, if you want to worry about things, one of them is the warming of the tundra and the places in the world where there's lots of methane that's frozen in place. Methane is a more powerful greenhouse gas than carbon dioxide. And so they say this is not climatologically relevant in terms of the amount of methane here, but if the temperature went up, there's more and more of these places that are bubbling. I mean, I don't know if you guys have ever seen, have you seen the pictures where people are lighting, they take one of those bubbles that go on this ice and you can light it on fire because methane is essentially natural gas. That's a really good. This is one of the Geminids captured on camera, and you can see this is nickel. The blue is more like calcium and magnesium, various kinds of elements. And then after this picture, you can actually see where it caused the atmosphere to glow and blow away there. Okay, so this is the comet. This is the Pleiades, the Seven Sisters. It's called the California Nebula right there. This would be an emission nebula. Those would be a reflection nebula. And this one is in our solar system. These are very far away, the other two. This is one of the most interesting pictures I've seen too. So I'm sure almost all of you have seen a sundog, right, where you see these two bright spots on both sides of the sun. They're caused by hexagonal ice crystals. This is like in December, I think, in Sweden. And this caught so many things that there are phenomenon here that nobody had actually ever measured before. I mean, this is a real picture. I mean, look at this. You got an inverted rainbow up there, and then a rainbow there, and then here's the 22 degrees, which is the usual sundog. And then there's this little coronal thing. I mean, this is an amazing picture. And we're getting close to the end here. This is somewhere in Czechoslovakia, or no, Czech Republic now, I guess. And you can see Orion right down here somewhere. And then you can see all the various meteors coming in. And then somewhere in here is also this is the comet right here, because there's the Pleiades, there's the Seven Sisters, and there's the comet. Okay, let me just go to the next one here. So for many of you, again, this is probably one of the most amazing images of our life. When Apollo 8 flew, and then as they came around the moon, you could see the Earth rise. So this is a digitally remastered picture of the first time that humans ever saw the Earth rise as they were circling the moon. The picture, the one before is a little movie that shows it in time-lapse, which is nice too. But I think this has really changed our perspective on the planet, to be able to go outside of it and look back at it and realize sort of how fragile and how small it is and all of those kinds of things. And then it's just really quite cool. This is another big galaxy. You can see all the various kinds of reflection nebulas, the dust nebulas, and so forth. And then let's not worry about that one. That's a pretty false color image. This is actually, I think, in the Orion Nebula. This is the Carina Nebula. Again, emission nebulas, star formation region right in there. And this is what's called a barred spiral galaxy, so it's a slightly different construction. This is an artist's rendering of the New Horizon flying through. So let's just go. I was trying to get to the picture that actually showed it, but apparently it says there's no internet. So I guess that would be a good place to stop. And this is probably just them telling me, God saying it's time to quit. So what I was going to show you is there's a video of the guy in the space station, the Canadian scientist who's done a bunch of different things, where he takes a wet towel and he wrings it out in space, where there's no gravity to cause the water to fall down. And so then you just see the water coming out of the towel and then working its way up his arms. It's just a really fun little video. But okay, any other questions? Yes.
What's the current estimate of how many stars there are in the entire universe?
We don't even know how much of the universe we can see. I mean, at this point, we are limited to 13.8 billion light years in either direction, in all the directions, because that's how fast light travels. When you look at a little tiny patch of sky, like they did with the original Deep Field, so that was a really dark part of the sky, and they just kept staring at it. They found thousands of galaxies in just that little patch of stars, or that little patch of sky. And so if each one has 100 billion stars, I don't know. I don't think I've ever seen a number for that. It would be one of those things that doesn't make any sense, right? Like a number so big that you can't really think about what it means.
If there are one or two other questions, I'll bring the microphone so that the camera can pick up your questions. Anyone else?
Okay.
All right, well, I don't know about you all, but I will be looking up more now that I've seen some of these. And so please join me in thanking Dr. Van Asselt. And a reminder to come back to the February program where Kenyon will be talking about Syria. So thank you all.